Greatest common factor. Greatest common factor. It is the greatest factor that divides two numbers. Example. Suppose we were to get the greatest common factor of 18 and 32. You know that 18 is 9 times 2, and 9 is 3 times 3. We get down the 2, and we will have 2 times 3 squared. So now let's do the prime factorization of 32, and that will be 4 times 8. 4 is breakable into 2 times 2. 8 is 4 times 2. This and this is 2 to the second, and this is another 2. In the end, this will be 2 to the 5th power. To find the greatest common factor, I will choose of these two only the factors that are common. Which are the factors that are common? It's the 2 only. And if I were to choose the one that has the smallest exponent, this will be 2. So the greatest common factor is 2. The next problem. Problem number 2. If we are going to get the greatest common factor of 16 and 32, we will say that 16 is 4 times 4, and that this is 2 squared, and that this is 2 squared. 2 to the 4th. The next one. We said already that 32 was 2 to the 5th in the previous problem. So if I was to say what are the factors that are common in both, I will say that the factors that are common in both is the 2. And if I was to choose the smallest exponent of both, it is 2 to the 4th. 2 to the 4th is 16. 16 is my greatest common factor. Now, I would like to mention the following now. If I was to put 16 over 32, the greatest common factor of both is 16, because 16 is the number that is divisible by this one and by this one, dividing both into 16. 16 into 16 is 1, and 32 into 16 is 2. So this greatest common factor is the factor in which, if I was to put 16 over 32, was the number, the greatest factor in which both are divisible by. Let's see our next problem. Problem number 3. Problem number 3 is get the greatest common factor of 48 and 60. Once again, I will find the prime factorization of 6 times, and this will be 6 times 8. This would be 2 times 3. This would be, as we have seen, 2 to the 3rd. Finally, this is 2 to the 4th times 3. That is my prime factorization. For 60, it is 12 times 5. And 12 is 4 times 3 times 5. And 4 is 2 squared times 3 times 5. Okay, that's our prime factorization for 60. Now, let's get the greatest common factor. The greatest common factor of these two is common factors, it's the 2 and it's the 3. If I was to choose the factor, I will do it for the one who has the smallest exponent, so this is 2 to the 2nd. 2 to the 2nd times 3, that is 12. 12 is my greatest common factor. Now, let's assume that we have a fraction such as 48 over 60. If I was to reduce or simplify 48 over 60, I will have to reduce the 48 into 12. And 48 into 12 gives me 4. And 60 into 12 gives me 5. And this will be the fraction that I am receiving as simplified. That's why the greatest common factor for 48 and 60, it's the number in which these two numbers can be simplified, because that is what greatest common factor is for, to reduce fractions. Next problem. Problem number 4. Problem number 4 is the greatest common factor of 15 and 24. If I was to get the prime factorization of 15, this will be 3 times 5, and for 24 would be 4 times 6, 2 squared, and this one would be 2 times 3. If I summarize this would be 2 to the 3rd times 3. So now we have both prime factorizations. The next question is, what is my greatest common factor? The greatest common factor of these two is what is common on both. What is common on both is the 3. So that means that if I was to have a fraction such as 15 over 24, the 3 will be the one that will be reducing this into 5, and this 24 into 3 will be 8. And that's the simplified form of 15 over 24, because the greatest common factor is 3. That means both numbers are divisible by 3.